Hello everyone, welcome back to another video. My name is Jubin, and in this episode 4 of the Azure Databricks series, we are going to look at the Spark DataFrames and using PySpark. This is the core skill that you will use in most of your data work on Databricks. So let's get started. DataFrame is table-like structure made of rows and columns. It's a spreadsheet or SQL table. You might have used one of those, and this might feel familiar very quickly. So Spark uses lazy evaluation and plans your steps first, and it only runs when you actually need your data and when you actually need the result. So this lets Spark optimize the whole plan before doing any real work instead of executing each line immediately. Spark is a distributed Spark is distributed, so the data frame the data is split across many machines, and it can scale very quickly to large sizes. This makes Spark efficient from tools like plain pandas, which can run on a single machine. And data frame is immutable, so every transformation you creates a new data frame, and this original one never changes. So this makes the code more predictable, and since earlier variables are never getting silently modified. And So this is the load, transform, and analyze flow. Every PySpark script follows the same three steps flow. So once you know this pattern, you can apply it to nearly every data task. Step one is loading your data from CSV to JSON to Parquet, and CSV, JSON, or Parquet, and you have your so it can read directly from the cloud storage or from the local files. And step two is transforming the data. So using operations like select, filter, or group by. And remember, none of this actually runs yet. Spark is just building a plan. And it only runs when you analyze the result in the display, where you aggregate or you create a chart. So that's when Spark executes everything when you ask for it. And it keep this flow in mind. We'll use this in the demo next. So here are the two core skills you will need for the data frames, and together they cover most of everything that you will do day to day. So reading the data is first skill, where you read the Spark CSV or JSON or Parquet, and it works with local and cloud storage. Spark infers the schema, and when you define or you define the schema. So when you Spark can guess it, but guessing is convenient, but it also, when you explicitly define it, it makes the process much more faster, and Spark is more reliable for large files in that case. And transforming the data is when you select, filter, group by, or do the joins. So covers these four cover vast majority of the real world data operations used for cleaning and shaping the data, and each step returns a brand new data frame. So you can either chain these operations together, but remember, nothing actually runs until you call an action like display or count. And this is the lazy evaluation idea from earlier. So let's go to the demo. So here is the notebook that we created in our last episode, where we looked at the data frame, where we loaded a sample Spark. Spark range of up to 10, and it loaded the numbers from 0 to 9, and this was we loaded in pure Python. And now we will look at how we can, so this is the query or the command that we are going to execute is, so I'll just copy this. So what this essentially is doing is we are creating a data frame, and we are reading the a Spark CSV from the data bricks samples, and we are going to use header equals to true and infer schema type to true. And so when we, so in header equals to true means it will return the first first column containing the um, column names, and infer schema means it can guess, it is automatically guessing the data types. But since this is a Databricks sample data set, I'm assuming, and I'm sure that the schema would be well taken care of. So I'm going to display this data frame. and it shows that it shows the data of 2014 rank, city, state code, population estimate, and 2015 median sale price. And now we are going to uh, run a new cell where we are going to filter the data. So filter the data, and we are going to run df.filter. So we are using our data frame from before, where we have 2015 median sale price. So copy this. And we are going to only look at the rows that have where the sale price was more than 300. So here you can see there are about so you can also download that CSV. You can do a filtered display over here, but I'm just going to, and then let's run this. So I'm going to create a new data frame called df2 filtered d15 underscore 300, and then going to let then display. Yeah, so it displays the data where, and it returned 14 rows, and over here it returned 294 rows, and this much time it took. And refresh just now. You can also download all the rows over here in CSV or Excel format. And now we are going to, in another cell, do a group by operation. So on the original data frame, not on the one that we filtered. And when we do the filtering, notice that it returns all the columns that were originally there because we did not select any column specifically. So we are going to group by state code. So let's see, state code is, and when we are going to do the group by, so it's going to group by the state where California, Colorado, Connecticut appears. So we are going to see how many groups have what data. So do the count over here. We can also do the sum. And by the way, we can also change the display operation. So let's run this. Yeah. So California has the most amount of sales. So this keeps so this shows the how many rows exist per state, and it returned about 46 rows, and there are 46 states that are there in our data set. And yeah, so this is how you would analyze the data, do the filtering, do the group by, and notice how each step builds upon the last one. And you can, when we loaded the data, transformed it, notice how we are analyzing it in few lines, and none of it actually ran until we called the display. So that's about it for the demo. Quick recap, the data frame is distributed, table-like structure built for scale. It looks like a spreadsheet, but it runs across many machines. And core workflow is load, transform, analyze. This is the pattern to reuse constantly. And transformations are lazy. Nothing runs until you actually ask for the result. And yeah, so that's about it for this video. Thank you for watching it. And if you enjoyed it, please like and subscribe if you really like this series. And in the next video, we will look at Delta Lake and why it matters and directly building on the data frames we use today. So take care and see you soon.